giga, T, tera, giga, J, sorry, tera, T, and then so on and so forth. Okay, so instead of writing deca, I'm going to use the symbol. Are we okay? What it means is that when I write a deca, you should understand that it's just a prefix. That means that it's just a word that is going to be attached to a main word. Are we okay? If I write D, it's deci. It means I can be attached to any main word. Okay, and since we are dealing with units, the word we are going to attach to it must be a unit. For example, and the unit must be the standard unit. For example, if I take, what is the unit of length? The meter, right? So that means that if I take D, I should be attaching, it's a prefix, so it should be attached to the main word, which is the meter. So I'm going to get decimeter. Decimeter. So this decimeter as a unit the right hand. Meter is actually a unit that is formed from, this is meter, the base units, and a prefix that's attached to it. So kilometer, km, is just the meter with the prefix kilo attached to it. So k, meter, and then k, which represents the kilo here attached to it. So when I have millimeter, it's the same that is happening. There is a main word, which is the meter, the base unit, and then the milli, which is the prefix attached to it. So what is happening is that we are not actually generating units. What we are doing is that we are just adding prefixes to the main unit, which is the meter, and then we are getting other units. So in other words, the units are not new. They are just the main units that we are adding prefixes to. Now it's very important that you understand that, or you see it that way, because it's going to help you understand how to convert between units using prefixes. If you pay closer attention, you realize that the same thing is happening not just with the length, but with other units as well. For example, if you take the gram, okay, the gram is a unit of mass. Okay, so the kilogram is just the gram that the prefix kilo has been added to. This happens with almost every other unit that you come across in science. Okay, let me give you a very common example. You know, a byte, okay, is the size of a data. Okay, the size of a data is measured in bytes. You've heard of kilobyte, you've heard of megabyte, you've heard of gigabyte, you've heard of terabyte. Okay, if you pay attention, you realize that kilobyte, the main word or the base unit is the byte, and then we have the megabyte, the kilobyte, terabyte. We have as big as the gigabyte. What's happening? You realize that you are just adding prefixes. Mega here, giga here, gigabyte to the main, which is byte. Okay, so we haven't generated new unit of measuring data. It's just the same unit that we have added prefixes to. Okay, I hope that is clear. Okay, I hope that this helps you to understand that there's a main word, and then we just add prefixes to it. Okay. So with this understanding, we can proceed and see how to convert between units using prefixes. Okay, but before we do that, let's look at this. If I write 12 millimeters, okay, I can decide to write this as 12 times 10 to the power negative 3 meters. Can I do that? Yes, I can do that. This is equal to this. How do I do that? Because I have not changed the question. I have not changed the value. It is 12, 12. And the milli is a prefix. It's a prefix which has a value. And the numerical value is 10 to the power negative 3. 0.001 is 10 to the power negative 3. So 12 millimeters is equal to 12 times 10 to the power negative 3. And then meters. Okay. So if I should give you 0.15 kilometer, you can express it in meters by just simply writing, substituting the value of the kilo, that is the prefix here, into the equation, and then the value, the unit will now be changed to meters. So 0.15. Yeah, I hope you guys can see that. 0.15 times 10 to the power 3 kilo times 10 to the power 3 meters. Okay, so I have my 0.15 here. This means that if there is no sign here, it means that it is multiplication. So multiplication, kilo, 10 to the power 3, and then meter here. So I can express values of written with prefixes in their base unit like this by just substituting their value into it. If you also observe, I've actually changed a number that is written in millimeters to meters by simple substitution. All I needed to know is to know the value of each of the prefixes here, and then I can do my substitution. Bingo. Okay. So with that being said, okay, let's flex our muscles. Okay, our brains, the muscles of our brains. Okay, with these examples. Okay, that's our understanding of what we've learned so far. Alright. So the question is this. Okay, so how do we do this? The question is asked us to express each of these values in different units. Okay, this is in femtometer, this is in megameter, this is in millimeter. You should express all of them in meters. In other words, the question is asked us to convert this to meters, this into meters, this into meters. Now we are not using a rote memorization, we are using our prefixes and the values they stand for to do the conversion. So it's pretty much easy, right? So starting with the first one, you can pause the video and then try it on your own and see if you get it. So 12.6 femtometer is equal to what? Meters. All you have to do is substitute. So that is 12.6 times the value of femto is 10 to the power negative 15, if you remember. 10 to the power negative 15. It's very, very, very small. About 14 zeros. Okay, in meters. So yeah, this is your answer. Most of the time, you might want to express this in standard form. Okay, so this in standard form is 1.26 times 10 to the power negative 16 meters. So I have converted femtometers into meters without actually knowing the conversion pattern between femtometers and meters. All I did is to use the value of the prefixes that I've been given. Okay, so it's pretty much easy. With that same analogy, 45.23 megameters becomes 45.23 times 10 to the power 6 meters. Simple. 20.3 millimeters becomes 20.3 times 10 to the power negative 3 meters. In standard form, this is 2.03 times 10 to the power negative 4 meters. Simple. Okay, so that's it. Alright, let's take another example. Let's express the following figures using appropriate prefixes. We want to express these using appropriate prefixes. The zeros are too many, so we want to simplify them using prefixes. How do we do this? Okay, so I'm going to use a prefix of your choice, the one that is the most appropriate to you. So actually, there's not a correct answer to this. Okay, so you have to choose a that is most appropriate to you. So looking at this, let's look at this. The first one. If I take 0.000, that is 4 zeros, 153 grams. Okay, how do I express this using prefixes? Okay, for example, how do I express this? Okay, now I need to use as least zeros as possible. So if I smooth the decimal point, 1, 2, 3, 4, 5, 6, I try to use 5. 5 zeros means that I'll need a power 10 to the power 5. That will be 10 to the power negative 5 because I've moved it 5 times. 1, 2, 3, 4, 5. Alright, so I will need to use a prefix that whose numerical value is 10 to the power negative 5. And see, there is none. If you observe closely, you realize that the prefixes are actually in powers of 3. So you see, starting from here, the ones that come after are in multiples of 3. Sorry, not powers of 3. Multiples of 3. So 10 to the power 6, 10 to the power 9, 10 to the power 12, 10 to the power 15. There's actually a prefix with the value 10 to the power 18, and then 10 to the power 21, and so forth. But I'm not interested in those. So we realize that this is 10 to the power negative 3, and then 10 to the power negative 6, 10 to the power negative 9, 10 to the power negative 12, 10 to the power negative 15. So they are multiples of 3. 10 to the power negative 5. The 5 there is not a multiple of 3. There is no prefix for it. So what I will do is that I will rather shift it a bit. So instead of putting my decimal point, I'll put it here. So I will get 10 to the power negative 6, and then I will find an appropriate prefix for which is the micro. Then I can write it in micrometers. So this is actually 15.3 times 10 to the power negative 6 grams, and this is equal to 15.3 micrograms. So I've expressed this using prefixes. So you see how handy prefixes come in science. They help you to simplify very large values, and they also help you to convert into units. They have a lot of other uses as well, okay, which you are going to see as we progress with our lessons. Alright. So the next one, you can pause the video and do the next one and put it in the comment section, and then come and check your answer. So B, 0.000246, 7 zeros, 761 meters. How do I write this appropriately? Alright, how do I do this? 7 zeros. So let's see. If I leave it here, if I move it here, I'll get 0 point something something. Okay, so I think the correct answer will be 761. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9. So 76.1 times 10 to the power negative 9. I'm trying to avoid powers that are odd, powers that are not multiples of 3. So 10 to the power negative 9. I could have used 10 to the power negative 6, but then I also have some zeros left. Okay, I want to use as least zeros as possible. So 76.1 times 10 to the power negative 9 meters. That is 76.1 nanometers. Mind you, the goal is not to write it in standard form. This is not in standard form, but I've written it using the appropriate prefix. If it were to be in standard form, it shall be 77.61 times 10 to the power negative 8. And negative 8 is not a multiple of 3, so it has no prefix, it has no numerical value that has a prefix. So this is the correct answer. You could have written it using micrometers, it would not be wrong, but this is the most appropriate answer.